This is Precalculus, Section 1.3, Day 2 notes. Today we are going to be talking about factoring algebraic expressions, okay? And I've given you all, I believe, a copy of the factoring flowchart to help you review the factoring methods. A lot of this information is also on my back classroom wall, just to remind you, but basically in this class, factoring is kind of a necessary skill, and so if you're struggling with this, please come in and see me so we can work on it. Okay, so let's go through our review. Our job here is to factor completely. When we start with number 1, looks to me like we have a GCF. What do those two terms have in common? Well, for sure we can take out a 3 and an x. So when we take out a 3x, the first term is going to have an x left, and the second term is going to have a minus 4. And since x minus 4 is linear, we are done. All right, number 2, 16m squared minus 25. We've got two terms, and there's a minus sign between them. 16m squared, that's a perfect square, and 25, that's a perfect square. So what we are looking at here is what I call a DOS, a difference of squares. We know that's going to factor into two binomials. One of them is going to have a plus, the other one's going to have a minus. 16m squared comes from 4m times 4m, and 25 comes from 5 times 5. Remember, you can always FOIL it back out to check it if you want to make sure that you are correct. All right, number 3 is a little bit tricky. Okay, when I look at this, your first thought might be, oh, maybe I should multiply that 2x plus 4 times that x minus 3. But remember, our job here is to factor. Okay, so on second glance, I notice that there's a common factor between the first part of this expression and the second part of this expression. There's a common factor of x minus 3. Okay, so what I see when I look at this is that we can actually do factoring by grouping. Okay, so if we look at it, we can really just say, well, okay, if I pull out that 2x plus 4 minus 5, then I have x minus 3 left. It's like somebody started this factoring by grouping, but they forgot to finish it. Okay, they identified that x minus 3 was the common term, but they didn't separate it from what was left. Okay, and now we can do a little bit of simplifying there with the plus 4 and the minus 5. So then we end up with 2x minus 1 times x minus 3. Now, could you have FOILed out 2x plus 4 times x minus 3, distributed negative 5, and then taken your 4 terms and factored by grouping? Absolutely you could have, but that is the long way to solve this problem. As I like to say, that's going to Toma through Canada. This is getting to Toma via the interstate. Okay, problem number 4. We've got 3 terms, k squared minus 8k minus 20. This is what I call an easy trinomial. We are just looking for a pair of numbers that multiplies to make negative 20. Now, if two numbers multiply to make a negative, I know that we're looking for a pair with one positive and one minus. The next thing I have to do is think of the ways to make 20. There's 1 times 20, there's 2 times 10, and there's 4 times 5. Well, if I need a pair that adds to make negative 8, that means it has to be that pair right there. And if I want a negative 8, then it's going to have to be a negative 10 and a positive 2. And we're done. No factoring by grouping required. Number 5, okay, this is another example of a trinomial, but notice here that a is not 1. Okay, so this one is a little bit more challenging. Everybody should have a method for factoring a trinomial when a is not 1. The first way that I'm going to show you how to do this is probably the way that you are least comfortable with. Okay, we are going to do this by trial and error. Okay, so the first thing I want you to think about is the ways to make 6. There's 1 times 6, and there's 2 times 3. So if we know that this is going to factor into two binomials, our options are either 1t times 6t, or 2t times 3t, right? And then we look at our constant term. The ways to make 5 are 1 times 5, and that's it. All right, so most of the time when you factor by trial and error, it's going to be the pair of numbers that are closer together rather than the ones that are further apart. So I'm going to guess, and I'm going to say that this is going to be 2t times 3t, right? And then to make 5, it's got to be 1 and 5. The question is, where does the 5 go and where does the 1 go? And we know one of them has to be positive and one of them has to be negative. So we just start plugging numbers in until we make it work, okay? But we want to be smart about it. If we know we need a positive 7t in the center, I'm going to try the positive 5 here, because 2t times 5 would give me a 10t, which means a negative 1 times 3t would give me a negative 3t, and that adds up to make my 7t in the middle. Okay, now I've had a lot of practice with trial and error. It comes kind of naturally the more that you work with it. But if you're not comfortable with that, on the second page of our notes today, we're going to go through other ways to factor trinomials when a is not 1. So just sit tight and we'll come back to that in a few minutes. Problem number 6, we've got two terms and we've got a minus sign, but this is not a DOS because 27h cubed is not a perfect square. However, it is a perfect cube, and so is 64. So this is a difference of cubes, okay? Now remember, whenever we are factoring differences of squares or differences of cubes, we are going to use SOAP. And that is going to give us our sign pattern. SOAP stands for same, opposite, always positive. Okay, that's what SOAP stands for. And SOAP works whether you're factoring a difference of squares or a difference of cubes. Either way, you can use SOAP. All right, so the first thing that we need to do is we need to figure out what term is being cubed and what term is being cubed. That's what we call our A and our B. Okay, so 27h cubed is 3h times 3h times 3h. And then 64 is 4 cubed. So now we've got our A and our B, and we know that when we factor a difference of cubes, we're going to have a binomial and we're going to have a trinomial. And our signs are going to be the same sign, and then the opposite sign, and then always positive. So now we've got our signs, right? The first parentheses is going to be your A and your B. So 3h and 4. And then you're going to end up with your A term squared. So 3h times 3h, that's going to be 9h squared. Your middle term is just your A times your B. So 3h times 4 gives me 12h. And then your third term in the trinomial is your B term squared. So 4 times 4 is 16. Okay, now what I want you to remember is that your trinomial is always prime. Because some of you are going to be tempted to try to factor that trinomial further, and you won't be able to. When you factor sum of cubes or difference of cubes, the trinomial that you get is always a prime trinomial. All right, number 7 looks to me, let's see here, m to the 6th power and 8 plus sign. I don't like the way this looks. I'm going to rewrite that as m to the 6 plus 8. I just like variable first, constant second. And this, hopefully you recognized, is a sum of cubes. So again, we are going to use SOAP to help us with our signs. But first, let's figure out what's being cubed and what's being cubed. To make m to the 6th power, it's going to be m squared times m squared times m squared. And to make 8, it's going to be 2 times 2 times 2. So now we've got our binomial times our trinomial. Our signs, same sign, so plus, opposite sign, so minus, and then third sign is always positive. All right, our binomials A and B, so m squared and 2. Then our trinomial is our A term squared, so m squared times m squared is m to the 4th. AB goes in the middle, so m squared times 2 is just 2m squared. And then b squared is our third term, so 2 times 2 is 4. And again, don't forget, trinomial, always prime. So here's our final answer here, and I'll go back and box that one up as well. All right, number 8, we've got 4 terms. Hopefully you remember 4 terms. Should always jump out at you. I should check for grouping. So do the first 2 have something in common, and do the second 2 have something in common? Indeed they do. I can factor an x squared out of the first 2, and then I'm going to have x minus 2. Now the rule of factoring by grouping is if it works, my parentheses have to be the same. So this parenthesis has to be an x minus 2. Can I make that work? Well, if I put a negative 3 in front, negative 3 times x would give me a negative 3x, and negative 3 times negative 2 gives me a positive 6, so sure enough it works. And now the last step, you take those 2 GCFs and they become one parenthesis, and your common factor of x minus 2 is your second parenthesis. X squared minus 3, although we have an x squared, it's not a difference of squares, so it can't be factored further. That one is done. All right, now we're going to go back and we're going to look at example number 5 again. Same example that we did by guess and check, but now we're going to do the method that I call the Steele steps, okay? So the first step when you do the Steele steps is you're going to multiply your A times your C. So you're going to take 6 times negative 5, that product is negative 30, and the sum in the middle is positive 7. So again, we're looking for a pair of numbers, but this time we're looking at negative 30. So it's still going to be a plus and a minus, okay? But it's negative 30 this time instead of what we had before. So we've got 1 times 30, we've got 2 times 15, 3 times 10, and 5 times 6. Looking for a sum of 7, hopefully you see that it has to be the 3 and the 10. And if we want a positive 7, then we're going to have a positive 10 and a negative 3. Okay? So now we're going to take that pair and we're going to split that middle term apart into 3 pieces. We're going to have 6t squared, and then we're going to have plus 10t, minus 3t, and minus 5. Now, you could totally write negative 3t and positive 10t. The order of the middle 2 doesn't matter as long as you have the signs correct. And now we are going to factor by grouping. So we look for what can we take out of the first pair? What do they have in common? Well, we can take a 2t out, and then we're going to have 3t plus 5 left. So this has to be a 3t plus 5 if this is going to work, which means negative 1 has to go outside the parentheses, right? So my final answer here is going to be 2t minus 1 times 3t plus 5. Okay, and that process, if you had me for Algebra 2, you know I call the Steele steps. If you had Mr. Service, he calls that the SC method or the super cool method. Okay, so that is the quadratic trinomial factoring when A is not 1 by using grouping. Okay, the last one I'm going to teach you is a fun little trick that I learned from a former math teacher, Ms. Miller, called Miller Magic. Okay, so you're going to start by multiplying A and C together. So once again, 6 times negative 5, that gives me a negative 30. But I'm going to do something a little crazy here. I'm going to drop that A value. So I'm going to write t squared plus 7t minus 30. Okay, so notice we multiplied A times C, but then we dropped A. Okay, so now I'm going to factor this, right? So again, I'm looking at negative 30 plus and minus, but I'm trying to make 7, okay? So it's going to be the same pair. It's going to be that positive 10 and that negative 3. So, but I'm going to write t plus 10, t minus 3, although we know that this isn't right? Because I have that A that I dropped. So I factor it, but you have to bring that A back in. So I have to divide both of these by that A value, which was 6. Okay. And now we're going to reduce. So this is t plus 10 over 6 reduces to 5 over 3. And negative 3 over 6 reduces to negative 1/2. And then our last step, this is the really cool thing here.